Welcome everybody, this is a quick video on how to run an Anova. We're using fields data, and this is Viagra data. So my first step is going to be to load Viagra data. To be clear, you use an Anova when you're dealing with a number by group, and you want to know if the number is different based off of which group, basically. The general form for this is AOV by group, where data equals D, or just put the D cache sign in front of both of those. Alright, so I'm going to load in my data, and again I told you it was Viagra as the data I'm using, so we name this Viagra data. Alright, so we can then, straight off the bat, want to relabel these. So if I run a summary on Viagra data, I have 1, 2, and 3 as doses. I'm going to want those as factors later. So this is me running a quick little bit of code to refactor those out. Again, this note is in the attached file, so you can go read that. In effect, we just said values 1, 2, and 3 are now associated with placebo, low dose, and high dose. So if I run the summary again, I now have placebo, low, and high. Okay. We're going to handle our assumptions first. The first assumption we're going to be testing is Levine's test. We're going to do that. First we need library car. And then we're just going to run the Levine test with our number by our data. P-value 0.89, we pass on that one. Next, if we want, and we should because this is a small sample size, we should test the normality of each subgroup. In order to do that, first we're going to make 3 subgroups. So I now have a none group, a low group, and a high group. I can now test each one of those with a Shapiro test. So Shapiro test, no problem on number 1, no problem on number 2, no problem on number 3. I've not violated assumptions yet. Next, I'm going to make my model. The general form for making a model is name of the model is going to become an Anova of your number data by your group data. Now that we have that, we can check our plot for normality. Hopefully this shows up on the video. So I'm going to click over here and click enter to start that up. The first thing I want to look at is that these have vertical lines that are approximately the same height. They do. The second one, I want to see that this line is pretty diagonal. I've got a little bit of janky over here, but overall I'm not terribly concerned at this point. Alright, so let's go back over to here. Alright, cool. So you'll note I had to finish that one up by continuing to hit enter before I let me come back. Okay, so not too concerned. I'm now going to run some post hoc tests. Post hoc test. Oh, first I need to summarize my model. I haven't done that yet, have I? I never do that. Weird. Alright, so we can write a summary of M, which gives me a p-value of 0.02. That tells me that at least one of these doses is different than the other, but I don't know which is why you run a post hoc test. So, as we run our post hoc test, we get this nice little comparison, which compares placebo to high dose at a significant difference. Low dose to high dose was close to significant, but wasn't. Okay. Now that we've got that, let us continue. So I'm going to start making some contrasts. So in order to make a contrast, I'm going to be kind of reader nice and create a new variable called dose underscore. That just means that when we read the contrast, it's going to have a space between it. It didn't change either of those variables, I just added another. So if I summarize Viagra data now, oops, spelled correctly, you'll just notice that I have another variable named dose underscore. It matches exactly dose. Okay. I'm going to create 2 contrasts that have names with them, so that it's very easy for us to see which one's which. The none versus some contrast, where none is this first option, -2, low is 1 and high is 1. These need to add up to 0. You need your 2 groups to be positive and negative. Anyway, so that's my none versus some, where some in this case is either a low dose or a high dose. And then low versus high zeroes out the none group and just takes the low versus the high. Should be okay. Now I'm going to bind the contrast I just made to the variable that I just created called dose underscore. Okay, all of that's great and good, but I need to make a new model in order to have the contrast in it, which I named MC for model with contrast. And in order to view that model, I'm going to run the summary.lm on my model with contrast. We can now clearly see that for my none versus sum, I was significant. And for my low versus high, I was not significant. That's a lot closer to significance than it was in our last post hoc test, and the reasons for that I'm not going to jump into right now. Okay, that is the end of that. Now for the robust. Let's assume that we violated an assumption somewhere in there, which we didn't. If we wanted to run a robust Anova, this one's kind of easy. It's just that 2 one way, except you'll notice I didn't load the library yet. The library for that is WRS2. Okay. And in that case, I am not significant. Just remember that robust sometimes is going to have slightly different numbers connected to it. Hey, it did it for me this time. That's nice. So the exact same command gave me a 0.0725 and then a 0.0736. So please don't be stressed if your p-value is slightly different than my p-value. Either way, we didn't need to run the bootstrapped test because, if you recall, we didn't violate assumptions. But if we had, we would have found not enough evidence to say the groups are different. Alright, that's the end of Anova.